The 1980s built harvesters with one mission: finish the harvest, no matter what. No touchscreens, no fragile sensors, just massive engines, thick steel, and mechanics farmers could fix in the field at midnight. These machines ran longer hours, handled worse crops, and survived abuse that would shut down many modern harvesters instantly. While newer models rely on software, these relied on pure engineering. Amazingly, many are still working today, outperforming machines that cost 10 times more. This is the story of 10 harvesters from the 1980s that still work better than new ones. Proof that old iron was built different. Number 1. Claas Dominator 98. The Dominator 98 from Claas is a late 1970s, early 1980s design that earned a reputation for heavy-duty build and exceptional serviceability. Its chassis and threshing components were deliberately conservative: large bearings, generous access panels, and modular subassemblies that independent mechanics could diagnose and repair quickly. That matters in a real harvest when every hour stopped for a bulky sensor or sealed electronic module can cost far more than the efficiency gains a new machine promises. The Dominator 98's rotor concave geometry and generous grain tank capacity made it a versatile all-rounder, capable of handling wheat, barley, and heavier small grains without requiring constant concave tweaks. Common longevity factors. The Dominator used over-engineered shafts and universal joints, and Claas kept spare components relatively standard across model years, so parts interchangeability improved field survivability. Typical failure modes on high-hour units are worn rotor bearings, header coupling wear, and electrical harness corrosion, especially where machines were stored outdoors. Practical inspection focuses on rotor runout, the condition of concaves and rasbars, and evidence of repair welding on the mainframe. Why it can outwork modern machines. In regions with limited dealer coverage, the Dominator's mechanical simplicity lets crews fix problems using basic tools and scavenged parts. Operators trade off advanced yield mapping and cabin comforts for near-continuous uptime during critical windows. For buyers, ensure a documented oil change history for the gearbox and look for recent bearing replacements. If the electrics have been retrofitted, verify workmanship and routing to avoid future shorts. Number 2. The John Deere 6620. The John Deere 6620 is a large, diesel-powered combine that embodies Deere's philosophy of rugged reliability from that era. With a beefy frame and straightforward powertrain, the 6620 was engineered to tolerate heavy loads and long harvest days. Its engine choices were proven truck derivatives, and the hydraulic and drivetrain layouts are intentionally transparent, meaning a field mechanic can trace problems without needing factory diagnostic software. Longevity strengths include robust gear cases and a mechanical header drive that resists shock loading during foreign object encounters. Recurrent issues on older 6620s are cylinder wear in the feeder house, worn hydraulic pump bearings, and turbocharger wear on high-hour engines. Buyers should prioritize compression checks on the engine, inspect for transmission oil contamination, and assess header nosebar condition. Why it still works better in some settings. Contractors and mixed-crop farmers report that a well-maintained 6620 will spend fewer hours waiting for dealer support compared with electronics-heavy modern machines. The parts ecosystem for classic Deere machines is also extensive, and many independent shops specialize in them, reducing both downtime and repair cost. If you plan to use a 6620 as a contractor workhorse, budget for a thorough driveline inspection and a fresh set of consumables, belts, bearings, seals to avoid surprises during harvest. Number 3. Case IH1480. Case IH1480 represents early adoption of rotary axial flow threshing in a package that scaled throughput without adding fragile electronics. The large rotor design gives consistent threshing across a wide range of crops and conditions. It's less sensitive to moisture swings than some Drum & Walker designs. Mechanically, the 1480's rotor and concave assemblies are accessible for cleaning, inspection, or part swaps, a real advantage in heavy trash harvesting. Typical wear items are rotor bearings and concave liners. Because the rotor operates at high inertia, bearing condition and shaft runout are critical. Excessive play accelerates wear on adjacent housings and simplifies catastrophic failure. Other common issues include header drive spline wear and cooling system fatigue on older radiators. Well-kept 1480s often have had gearbox servicing and rotor spindle repacking. Those are good signs the machine was treated proactively. Why farmers still choose it? Where throughput and tolerance to mixed material matter, the 1480's rotor keeps crops moving and reduces frequent clogging. In markets where technicians and parts are local, a used 1480 can outperform a new machine that's offline while waiting for dealer service. Inspection checklist: measure rotor runout, check bearing temperatures post-run, verify concave clearances across the width, and confirm that the header drive engages cleanly under load. Number 4. Case IH1680. The Case IH1680 is a development of the rotary lineage with increased horsepower, wider headers, and improved cooling, all aimed at higher daily throughput. It retained the simple serviceable layout of earlier models, but beefed up critical components to handle bigger acres. For many contractors in the 1980s and beyond, the 1680 struck a balance between capacity and maintainability. Heavier bearings, larger grain tanks, and reinforced frames reduced the frequency of severe downtime events. Common long-term problems are related to the drivetrain and main rotor housing fatigue if the machine was used heavily without regular maintenance. Radiator clogging, worn hydraulic control valves, and cornhead coupling wear are typical. A strong condition 1680 will show recent gearbox service, replaced seals, and documented rotor bearing work. Why it keeps earning work? The 1680's upgraded components make it more tolerant of hard use than both earlier vintage machines and some modern units that rely on sensor controls rather than mechanical robustness. For buyers, confirmed documented torque on drive fasteners. Loosened fasteners are a frequent cause of secondary damage. Number 5. New Holland TR98. The New Holland TR98 is part of New Holland's push toward larger rotor and twin rotor solutions in the 1980s. Built for high capacity, its design favored easy maintenance access and modular header attachments. The TR98's twin rotor architecture excels at handling damp or variable material loads without excessive threshing loss, making it valuable in mixed crop regions where conditions change quickly through the day. Typical wear items include rotor seals, concave liners, and hydraulic valve bodies. Because the TR98 was built with serviceability in mind, many owners have kept thorough parts logs, a boon for buyers. In many cases, independent rebuilders supply reconditioned rotor sleeves and bearings, keeping older TR98s economically viable. Why operators still run TR98s? The machine's clean power delivery and low sensitivity to trash reduce stoppages in rough harvests. Replacement parts and aftermarket rebuild kits are common in regions where New Holland sold heavily, so the economics of keeping a TR98 running are attractive. Inspection emphasis, rotor balance, concave wear patterns, and header drive spline condition. Also check for any aftermarket electronic add-ons that might have been poorly fitted. Number 6. Massey Ferguson 760. The Massey Ferguson 760 and its immediate successors was developed as a high-capacity, no-nonsense combine for large farms and contractors. The design prioritized heavy headers and straightforward powertrain service. The 760's frames and header mounts are particularly robust, allowing operators to attach large front-end heads and keep them running in tough conditions without frequent realignments. Common long-term issues include gearbox seal degradation, header gearbox wear, and fan and belt service needs. Where owners performed routine gearbox oil changes and monitor fan belts, these combines can deliver surprisingly low-cost operation. The MF760 is also known for straightforward hydraulic layouts that many independent mechanics can diagnose without factory tools. Why it's still useful for long days and heavy material? The MF760's strength and simplicity mean less stoppage time. It's a machine built to be serviced with farm tools and local parts, which in many locations translates to more practical field hours than a new combine that's waiting for a software update. Buyers should ask for records of gearbox service and verify the integrity of header lift cylinders. These are common failure points on older examples. Number 7. Laverda M12020. The Laverda 120 is an Italian design notable for its heavy gear cases and European serviceability. Laverda emphasized solid metallurgy and direct access to major service points, producing combines that performed well under consistently high yields. The M120's rotor and concave systems were engineered to be rebuilt rather than replaced, which encourages long service lives when operators invest in periodic overhauls. Wear items commonly seen are rotor bearing wear, rotor housing corrosion in humid climates, and header cutter bar fatigue. Fortunately, in many European markets there is a healthy trade in used Laverda parts and reconditioned components, a factor that keeps M120s viable far beyond their expected life. Laverda machines also often received thoughtful retrofit work by owners, such as improved sealing and updated alternators, which helps reliability. Why it stays competitive? Where access to Laverda parts exists, M120s can be kept running with minimal downtime because they were designed to be maintained rather than replaced. Buyers should specifically check rotor spindle end play, gearbox oil condition, and evidence of water ingress in electrical junctions to avoid expensive future repairs. Number 8. Gleaner N6. Gleaner's N6 and related N-series models follow a philosophy of compact, heavy-duty construction with very accessible service points. The N6's conservative engineering produced combines that were straightforward to maintain, cast housings, large access doors, and a direct drive mentality. Many operators praise Gleaners for their predictable maintenance needs and the ease of replacing wear items without removing major assemblies. Typical attention points are concave wear, fan and sieve wear, and header feed wear. Gleaners are often favored by smaller contractors and large hobby farms because the cost to keep them running is low compared with the technical overhead of a modern machine. There's also a social advantage because Gleaner combines were popular in many farming communities. Knowledge about repairs and common fixes circulates widely. Why they outperform some modern units in practice. A crew that knows the machine can service it quickly during harvest, avoiding lost hours that come from waiting for a remote dealer. For prospective buyers, check sieve adjustment ranges, confirm that feeder house chains are within spec, and test the grain sample outlet for cleanliness under load to detect hidden losses. Number 9. International Harvester 1460. The International Harvester 1460 is part of the company's push toward robust, operator-serviceable combines with proven durability. The 1460's strengths lie in its tried-and-true driveline and a design that favored in-field repairability. Because IH machines were once ubiquitous, parts and aftermarket support for the 1460 are plentiful in many markets. Known wear items include rotor and separator bearings, header drive components, and hydraulic seal leaks. Users who kept up with oil changes and periodic bearing repacks often report decades of service. The 1460 is prized where operators want predictable, repeatable performance with minimal electronics that can fail at inconvenient moments. Why it still beats some newer machines. Fewer electronic failure modes, straightforward diagnostic checks, and a wide aftermarket mean a 1460 can be returned to service quickly after a breakdown. Buyers should compress test engines, inspect for transaxle slippage, and review any retrofit history. Many owners fitted upgraded belts or alternators that materially improved reliability. Number 10. Rost-Selmash Don 1500. The Rost-Selmash Don 1500A and similar Eastern European designs were built for harsh environments with minimal dealer infrastructure. Simplicity was the design brief. Large, heavy components, simple electrical systems, and a tolerance for local improvised repairs. That engineering philosophy means these machines often survive in remote high-abuse settings where a modern combine would be out of action waiting for a diagnostic cable or OEM module. Common issues are age-related corrosion, sealing failures around gearboxes, and worn header components. However, because the Don 1500A used simple, well-understood mechanical systems, local workshops frequently have the capability to fabricate replacement parts or adapt alternatives, an advantage in areas where original spares are scarce. Why it can outwork modern alternatives. The Don 1500A's straightforward construction enables fast, local repairs, often using parts that can be sourced or fabricated close by. Where uptime depends on the ability to keep a machine running with what's on hand. These Rost-Selmash machines are pragmatic winners. Buyers should verify metal fatigue at major mounting points, test gearboxes under load for abnormal noises, and inspect electrical junctions for rodent or moisture damage. So that's it for today. If you like this video, then please hit the like and subscribe button for more videos. Thanks for watching.